which is the theorems about roots of polynomial equations. The big one we're looking at, and the main one, only one we're looking at, is something called the rational roots theorem. Okay? And when we talk about roots, remember roots are words for zeros, solutions. Okay, we're talking about finding roots, we're talking about solutions, zeros, all interchangeable words there. And what this says, given a polynomial, all possible rational roots, known as PRRs, can be found by taking the factors of the constant coefficient divided by factors of the leading coefficient. And that gives us P over Q. So, keys here. In order to do this, we're going to do factors of the constant coefficient, and we call that P, divided by factors of the leading coefficient, and we call that Q. And so thus, if you hear me talk about P over Q, that is factors of the constant coefficient divided by factors of the leading coefficient. What we're doing here is we're identifying all possible rational roots or potential rational roots. They might be solutions. They might just be extra values that aren't actually solutions. And so that's what we're looking at. So on this first set of examples, we're just going to list all of them. We're not going to do anything with them. We're just going to list our possible solutions. When we get down to the next part, we'll look at how we can use them. Okay? So, and this will, I think, make a little more sense when we start to put it all together down here. But for right now, let's look at list all possible rational roots or solutions for each equation. So I left this as solutions. I could have just as easily said roots here, okay, or zeros even. We could use the word zeros. So notice in order to do this, it said to do, okay, I'm going to label this as PRRs, and it said it was P over Q. And I'm just putting that notation in there because you sometimes see that. So X equals P over Q, where P are factors of the constant coefficient. Thoughts on what the constant coefficient is in this problem? Or just thoughts on what the constant is? If you look at 4x to the fourth plus 13x cubed minus 124x squared plus 212x minus 8 equals 0. What's the constant in this problem? What do I mean by a constant? Nothing? No one's gonna... What's a constant? It's probably my phone vibrating too. My phone's laying on my desk. What's a constant? What's a constant as opposed to a variable? What's a variable? A letter? I'll take the quiet answer back there. Okay. A variable is a letter. A constant is not a variable. It's not a letter. It's a number. Okay. Now, we want the constant coefficient is just a constant. No variables associated. So what's my constant here?
4.
No. What'd you say? 8. Why 8? Oh. Right there, guys. This 8 is my constant. It's the constant because it's a number by itself. It doesn't have a variable attached to it. Now, technically, I'm going to tweak it and say -8. But in all honesty, I don't even really need the negative for what we're getting ready to do. But, you know, there is the 8 there. So on top, when we do set this up here in a moment, we're going to be looking for factors of -8. Factors of basically the constant. So if it's written in standard form, it'll be the last number. But most importantly, it's the number without a variable attached to it. Okay? Now, factors of the leading coefficient. What's my leading coefficient?
4.
4? Why 4? Yeah. So my leading coefficient is this 4 right here that is in front of x to the 4th. X to the 4th has the highest power, right? So that makes it my leading term, 4x to the 4th. The coefficient is the 4. So we're looking at that 4 right there. And so in the denominator, we're looking at factors of 4. Okay? Well, let's list them out. On top, factors of -8. Honestly, don't worry about the negative. It doesn't matter if we say -8 or +8 here. Factors of 8. What?
1, 2, 4, 8.
Does that make sense? When I say factors of 8, what numbers multiply to be 8? 1 and 8, 2 and 4. Any other pairs of numbers that multiply to be 8? No. Now, because it is factors of -8 and just factors in general, technically these factors can be positive or negative. So instead of just listing 1, 2, 4, and 8, I'm going to say plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. Okay. Factors of 4 then.
2, 4.
Okay. If we think about what multiplies to be 4, it's 1 times 4 and 2 times 2. Again, positives and negatives, because you can't have a negative times a negative be 4. So I'm going to say plus or minus 1, plus or minus 2, plus or minus 4. Now, that's not how I'm going to express my final answer, but this represents all the possible rational roots. I always like to go and list them, so I have a nice neat list, and that means pretty much pairing up all the pieces. So the fact that all of these numerators can go over any of these denominators. So in other words, it's not just doing 1 over 1, 2 over 2, 4 over 4. It's the fact that 1 can go over 1, 2 can go over 1, 4 can go over 1, and 8 can go over 1. They can all go over 2, and they can all go over 4. So I'm going to list all those pieces out. So if I start here, what is 1 over 1? 1. I'm still going to say plus or minus, so plus or minus 1. 2 over 1. What's 2 over 1? 2. So plus or minus 2. 4 over 1? Plus or minus 4. 8 over 1? Plus or minus 8. So that takes care of putting them all over 1. Now, take a turn and put them all over 2. 1 over 2. Plus or minus 1/2. What was that? 1 over 2. Okay. 2 over 2. 2 over 2 is 1. What do we know about 1? I already listed it. Okay. What about 4 over 2? 2. Did I already list it? Okay. 8 over 2? 4. And I don't need to list duplicates, okay? Now, am I done? No, because I haven't put everything over 4. 1 over 4? Plus or minus 1/4. 2 over 4? Reduces to 1/2, and 1/2 I've listed. 4 over 4 is 1. 8 over 4 is 2. Okay, guys, this is my list of what we often refer to as possible rational roots or potential rational roots. If we graphed that equation there, these would not all be solutions. These would not all be zeros, but some of them would be. Any of the rational solutions would be covered in this list. And again, down the next problem, we'll look at how we're going to use those, where they're helpful. Okay, questions there? And what order you do this in is up to you. You know, I kind of took and went over each denominator. If you'd rather alternate the numerator, you know, do something differently, that's fine. Now, when you do a quiz for me, yes, I might make you list these all out. Good news about Savvis, they don't make you type them all in. It's a multiple choice situation. Now, I will say in their multiple choice situation, they don't say plus or minus 1. They say 1, comma, negative 1. Instead of plus or minus 2, 2, comma, negative 2. So they're going to have them all listed out as opposed to the plus or minus that we shortcut with. Okay, so just kind of some FYI there about homework. Okay, let's try B. Do you know how to find the PRRs, the potential rational roots here? Officially, it's P over Q. Officially, I'm going to say factors of what goes on top? Okay, factors of negative 45 over, and why did we pick negative 45, by the way? It is our constant, right? No variables with it. You're looking at the term without variables. Over factors of 7. Why 7? Okay, it's our leading coefficient. Okay, you got the leading in there. That makes me happy there. Okay, I'll take it. Okay, factors of 45. 1 and 45, right? There's always going to be, you've always got an easy set, right? 1 in itself. Okay, we know it divides by 5. 5 times 9 is a set I would like to think we know as high schoolers. And it divides by 3. So 3 and 15. Because if it divides by 9, it's going to divide by 3 because 3 goes into 9. Did we get them all? Okay. I'm going to go in order and we'll figure it out as we go. Plus or minus 1. What about 2? We didn't mention 2.
No.
And here's a helpful hint, guys. It doesn't divide by 2. If it doesn't divide by 2, it's not going to divide by anything even. Okay? So if it doesn't divide by 2, you don't have to check any more even numbers. So 1, we already said 3. 4 is even. You don't have to worry about it. 5, we already mentioned 5, didn't we? 6, no, it's even. 7, does 7 go into 45? No, does hard to check though, right? 8, no, it's even. 9, and notice 5 and 9 were one of my pairs, weren't they? So yeah, I feel confident. I just have to list my others. Let's see, 5 and 9, 3 and 15, and 1 and 45. It's not that you have to list them in numerical order. It just, my brain does better that way, personally. Okay, denominator's a little easier. What are factors of 7? 1 and 7. Feeling pretty confident there? That's it, guys? Okay. Now you have to go through and write them out. I don't care what order you do this, how you do it. If I'm grading it, I'll find them all. If you're on Savvis, you'll have to figure out which one has the ones you need. So if I go through and put everything over 1, 1 over 1 is 1, plus or minus, of course. 3 over 1 is 3. 5 over 1, 9 over 1, 15 over 1, 45 over 1. So I've got my plus or minus 1, 3, 5, 9, 15, and 45. And then what do I do with all those same numbers? Put them over 7. We're not going to run into any repeats this time, are we? So plus or minus 1 over 7, 1/7. 3 over 7, so 3/7. 5/7. 9/7, 15/7, and 45/7. that is my list of potential rational roots. Okay? They're not all going to be roots. They're not all going to be solutions to this equation. I mean, come on, guys. This is an x to the third equation. At most, there are 3 answers. But these are just up to 3 of those could work. Okay. Make sure you have your whole list there. We can start looking at the next one when we're ready. The bottom questions ask about what are all of the complex roots. Not just the possible roots, but which ones actually work. So as we look at this next set, we're actually going to start with our potential rational roots, or possible rational roots. We're going to start with those, and we're going to have to then determine which ones actually work. Okay, which ones are the keepers that we want to use, which ones can be trashed, aren't going to work. Okay, so that's what we're going to do next. Okay, so let's look at the next problem. Notice the question says, what are all the complex roots of the polynomial equation? And then write this in factored form. I'll give you the heads up, I should have probably given my morning class. I have a lot to write in this area. So my morning class started complaining as they got to the end of this, I don't have any more room. So I guess I'm giving you the heads up. Conserve room, right? Easier said than done sometimes, but conserve room. Okay, so we're going to start. It wants to know all of the actual complex roots at work. Keep in mind, complex is going to include our imaginaries as well. But in order to figure this out, I'm going to kind of think in terms of steps with you guys. And the first step is to find my PRRs. So in order to find my PRRs, third time in a row, guys. You got this now, right? Factors of what over what? Okay, factors of my constant, which is -2, over factors of the lead, which is 3. Good news, there's not as many choices here, right? What are factors of -2? Yeah. 1 and 2. So plus or minus 1, plus or minus 2. What are factors of 3? 1 times 3, so plus or minus 1, plus or minus 3. We'll enjoy not having nearly so many, right? Now, give me an actual list. Whoops. Don't stop there. If I put everything over 1, 1 over 1, plus or minus 1. 2 over 1, plus or minus 2. And then if I put everything over 3, 1 over 3, plus or minus 1/3. 2 over 3, plus or minus 2/3. And these are my PRRs, potential rational roots, or possible rational roots. Some of them are going to work, but not all of them are going to work. Okay? Okay with step 1. Okay. Step 2 is we have to figure out which ones work. How many PRRs do we technically have?
8.
We technically have 8 if you think about the plus and the minus, right? Because that is 8 separate numbers. Now, we could try out all 8 of these and see what works. Or we can shortcut it a little bit. Okay. Now, how are we going to try these out? How do we know if these roots work and create factors or not. Think about what we've done the last couple of days. How do we know if they work? How do we know if something is a factor? And how does synthetic division help this? Because it tells us the remainder. If it's a factor if the remainder is 0. If the remainder is not 0, it's not a factor. Now, do we want to do 8 sets of synthetic division to see which works? We could, but not my recommendation. For one, at most, how many possible answers are there to this problem? 4, because my highest power is 4. So I know there's no more than 4 answers. But I don't really want to use that. So what we're going to do is we're going to take a peek at the graph. Okay? And what is the best graphing utility we use in Algebra 2 probably? Desmos. If you have a graphing calculator, you know how to graph on it. You know, you could graph these on the graphing calculator as well. But we're going to use, as a class at least, I'm going to instruct with Desmos because Desmos is what everybody has access to. And what we're going to do is we're going to graph it on Desmos, and we're going to check the graph on Desmos to see which PRRs line up. Okay? So, you can go ahead and get Desmos out if you want. I'm going to switch over to Desmos. If I'm lucky, I still have it graphed from earlier. Is that the right one? Yeah. Okay. You guys remember how to use Desmos, right? I really don't have, I'm not going to take the easy way. I'm going to use what I have from earlier. Okay. So, you're typing it in, you're graphing it. You've got your exponent button here with the a to the b, right? So type it all out. Or take a peek at mine, I guess. You know, as I said, I happen to have it graphed from earlier today. We have a list of zeros, right? They're not on my screen right now because I'm on the other page. But we had what? Plus or minus 1, plus or minus 2, plus or minus 1/3, plus or minus 2/3. I'm looking for, okay, which ones match up? Now, what are we talking about? Potential rational roots, solutions, zeros. Where are those on this graph? Where are they? The x-axis, right? Where the graph crosses the x-axis. As you look at your graph, what do you notice? There's 2 of them. Where does it look like the left one crosses? Looks like -1, doesn't it? And I can feel, even without, and here's the deal. Yes, we can tap on it and find them, but I'm just trying to take a quick glimpse at the graph. Oh, -1. That definitely looks like 1, right? So when I go back to my other screen, I'm going to say that we're going to try x equals -1. Now, what about this next one? It's not a whole number, is it? Does it line up possibly with anything we have? Okay. What are you thinking? 2/3 maybe? I mean, my choices, it's not 1, it's not 2, so my choices are 1/3 or 2/3. What's it look closer to? Probably 2/3. So my guesses are that my rational zeros are going to be -1 and positive 2/3. The others, there's only 2 shown here, guys. And remember, we're supposed to have 4 answers. That means my other 2 are imaginary. We're going to have to find those. Okay? So, let me switch back to my notes, but that's how you're going to use Desmos there. we're going to try, what do we say, -1 and +2/3, except I meant to write try. We're going to try x equals -1 and x equals 2/3. I don't guarantee they're going to work, but we're going to try. That's the mindset we've got to go in here. And I think very small over here, I'm going to sketch a graph. And the idea here is I don't know, my graph looks something like that, right? It looks like that might be -1 and that one might be 2/3, right? That's what we're guesstimating. And that's why we're trying -1 and +2/3. Okay. Step 3, when I say try them with synthetic division. Test them out and see what happens. Now, I would start with the one I'm more confident with, and I'm confident with -1, right? I'm always more confident with those than fractions. So I'm going to start with -1. I'm going to put -1 in my box. What numbers go next to -1 for synthetic division? Okay. 3, 4, 2, -1, -2. And the numbers that represent the dividend there. Do the math, right? Do we remember our synthetic division? We got it figured out? Drop the 3, then multiply. -1 times 3 is -3. Then add. 4 plus -3 is +1. Multiply. -1 times 1? -1. Add. 2 plus -1? 1. Multiply. -1 times 1? -1. Add. -1 plus -1? -2. -1 times -2? +2. -2 plus 2? 0. What's that 0 mean? Remainder is 0? -1 worked, didn't it? Okay, so that means one of my zeros is x equals -1. Okay, that is one of my zeros or my roots, depending on how they ask it. While I'm here, what is -1 represented as a factor? Because they also ask for factored form. Yeah. If you have a 0 of -1 as a factor, that is x plus 1. So it depends. If they ask you for the roots, the zeros, you're going to tell them x equals -1. If they ask you for the factor is x plus 1. Okay? Trying to help you get the terminology straight here. Now, don't get ahead of me. -1 worked. What else were we guessing? 2/3. So we're going to try 2/3. Now, there's a catch here. First of all, give it a chance. It's not difficult just because it's a fraction. But with 2/3, what numbers do I use? We talked about this in one of our examples yesterday, in that I don't want to go back and use the original row of numbers because I'm trying to factor it down. And as I'm trying to factor it down, that means I'm going to use our new row of numbers. And again, that's because in the end, we have to be able to find our two complex solutions. So now we're going to use 3, 1, 1, -2. Drop the 3. And if you're sitting there saying, oh, fractions, really, Mrs. Sargent? When you have to do synthetic division with fractions, and if they are ones that work out the remainder of 0, I've never seen the math be nasty. It's always nice to us. Now, if you don't know how to multiply fractions, well, okay, that's a whole other story, and you should know that by now. You've been taught it. You just have to choose to learn it. 2/3 times 3. 3 over 1, right? My brain just says cancel the 3's. Some of your brains say 6 over 3, but 6 over 3 is 2. Okay, 1 plus 2? 3. 2/3 times 3. Didn't we just do that? 2. 1 plus 2? 3. 2/3 times 3? Feeling a little repetitive here. And negative 2 plus 2? 0. Okay. First of all, good news is remainder of 0, the 2/3 worked, didn't it? If you have to give me that 0, x equals 2/3. What about if you're asked for a factor? X minus 2/3. Or at least that's what they're accepting here, so we'll take it. Okay? Now, we don't have any more roots to try, do we? So at this point, we have to figure out what 3, 3, 3 represents. This is 3, 3, 3 what? 3x squared plus 3x plus 3. Okay, we know it's x squared because this was originally 3x to the 4th. So the first answer was 3x to the 3rd. So this was 3x to the 3rd, which made that 3x to the 2nd. Now, if they're asking you for factors, that right there is probably the 3rd factor they want. Okay? However, they're not necessarily just asking you for factors. It depends which problem they have. If they ask you just for factors, you're done right here. Most of them, I feel like, we're asking for zeros and factors. So what I'm going to call step 4 is we have to take this piece right here and find the solutions for it, which in this case are going to be the imaginary. So I'm going to say 3x squared plus 3x plus 3 equals 0. And I need to solve that. Now, notice a whole bunch of 3's, yes? You can work with the 3's. Or actually, because this is an equation equal to 0, technically you could divide the 3's out. You could divide the 3's out, and it just makes our numbers easier to work with, and say this is x squared plus x plus 1. But whether it's with the 3's or whether it's with the 1's, how do I solve? Trying to figure out if Jonathan's thinking the right thing or not. Quadratic formula. They're imaginary. They're not going to be rational. They're not going to be real. So factoring's not going to work. Quadratic formula is where we have to go here. So, talk you through it. Negative b, which is negative 1 plus or minus the square root of b squared minus 4ac. So b squared, 1 squared, minus 4 times a, which is 1, times c, which is 1, all over 2a, which is 2 times 1. Clean it up. I am running out of room. This is the last bit we have to do on this problem, but I'm running out of room. I did better on my paper, but negative 1 plus or minus, what's under that square root? 1 squared minus 4 times 1 times 1. 1 minus 4, which is negative 3, all over 2. So negative 1 plus or minus. How do I deal with square root of negative 3? Not exactly. The I is good because it's a square root of a negative, so we put the I out front. What is the square root of 3? Square root of 3. We don't know it. So I'm going to say I square root of 3 all over 2. There are my imaginary solutions. Those are part of my answers. What were my other solutions? Yeah, the negative 1 and the 2/3. There are your complex roots, if you will, okay? Or there, I guess I will call these, those are my roots. They're asking you for your roots, your solutions, your zeros. Those are the roots. Now, if they ask you for factored form, I already essentially gave us factored form, didn't I? What was factored form? X plus 1, x minus 2/3, and 3x squared plus 3x plus 3. So if they wanted factored form, you are saying x plus 1 times x minus 2/3 times the 3x squared plus 3x plus 3. So it all depends which part of the question you're answering. Some questions have both on there, some questions only have one. I told you I was going to take up all that room and then some, didn't I? Hopefully you were able to make it work better. I can always make it work better on my paper than I can on the BenQ. Okay, there's a lot to that one, I know. Okay, it's a process. We'll practice the process again on B. And in fact, what do we have? About 3 minutes. As I say, if you want, you could go ahead and start on the part B, which, what was our first step? PRRs, right? PRRs is the piece of, PRRs and then checking on Desmos. So we'll start there tomorrow. We do still have the backside to do. The backside requires some work, but it's more straightforward, okay? So we'll look at that tomorrow. My plan is to get through the notes tomorrow, and I think we can. Okay? Make sure you get 3-5 done for today, and 3-6 is out there and available.